Hi there, Year 10. So I've been asked by a few students in the class to go through homework 16. Some of the questions have changed from your previous homeworks, and there are some questions there you might not be sure about. So I'm going to go through all of the questions on homework 16 and explain how to do each of them, and hopefully that will give you a way forward with the next sets of homeworks, as they will have similar questions to homework 16. Okay, so I've just printed out a slightly enlarged version of the questions that you had on homework 16, so we can talk through each one as we go. So starting off then with the numbers and calculating section, I've also got some scrap paper in case we need a bit more room. But the first one we've got is write down the value of 2 to the power of minus 1. Okay, I'm not sure if you can see that little minus in there, but there's a little minus there. So 2 to the power of minus 1. Whenever we have anything to a negative power, it means we need the reciprocal. Okay, so the reciprocal of 2, the opposite of 2, remember 2 itself should be 2 over 1, so its reciprocal is 1 over 2. Now that was to the power of 1, so we're keeping our power of 1 there. So it's just the negative that tells us it's reciprocal, the power remains. But if I do 2 to the power of 1, that's 2 times itself 1 time, I would get 2, so my answer would be a half in this case. Okay, question 2 then, we've got 8 to the power of 2/3. I'm just going to write that out again. Now, when we do them with fractions, the denominator is always the root, the numerator is always the power. So if I've got 3 as my root, that tells me it's a cube root. So I've got a cube root of 8, and that's still to the power of 2. So you can see that my 3 here has become my root. My numerator of 2 is still my power. Now we try to do any cube rooting, square rooting, whatever the root is first. We try and deal with that first. The cube root of 8 is 2, and that's still squared because I haven't dealt with the power yet. So cube rooting 8 gives me 2, so I get 2 squared, and 2 squared is 4, so I have an answer of 4. Question 3 then, 8 to the power of 0. We should know that anything to the power of 0 is 1. Okay, so it doesn't matter what number I have, if it's to the power of 0, I get the answer of 1. So that's our powers questions. Okay, moving on then, we're going to look at surds. So we've been asked to write root 50 in the form k root 2. So we know what one of the roots is here, we need to find the value of k. So we're going to break 50 down into 2 times 25. I know there's a 2 because it tells me I've got root 2 here, so that's helping me to tell me one of the numbers, and to get 52 times 25 is 50. If we split that out into 2 separate calculations, that's root 2 times root 25. Now of those, I can square root the 25, the square root of 25 is 5. I can't square root 2, that remains the surd, and we get 5 root 2 as our answer. So we're using part of the question to help us to break down that number into 2 separate surds. One of them will always be square rootable to be able to give you a value of k. Question 5 then, rationalise the denominator and simplify. Rationalising the denominator means we don't want a surd as the denominator. So to get rid of the surd as the denominator, we need to multiply the top and bottom by that surd. So we're going to multiply both the top and bottom by root 5. 1 times root 5 is root 5. Root 5 times root 5, well, effectively 5 times 5 is 25, but that means I can now square root 25. The square root of 25 is 5. So we get root 5 over 5. So you might remember the shortcut is that if we're multiplying the same roots together, they will always cancel because squaring and square rooting will undo each other, so we always end up with just the single value number. Our next one for surds then is adding. When we're adding or subtracting surds, they must be the same surd. It's the same idea as adding and subtracting fractions with the same denominator. I've got root 2 plus another root 2, so it's how many root 2's do I have? Well, I've got 1 here and 1 here, so that means I've got 2 root 2. Okay, so we're simply adding up how many of the items we have. Okay, now we're going to move on then to bounds. So 840 has been rounded to the nearest 10. Give the lower bound. Whenever we're giving bounds, so we've got our 840, if we've been rounded to a whole number, we half that number, we add it for the upper bound and subtract it for the lower bound. So my upper bound would be 845, half of 10 is 5, so I've added 5 on. My lower bound, if I take 5 off, is 835. Now you'll notice I've used a less than or equal to symbol for the lower bound, but only a less than symbol for the upper bound. That's because with upper bounds we don't want to have 0.499999 recurring. We want it to be to the nearest 5, so we need to therefore say that it's less than, because it can't be this exact value. Now we were asked to just give the lower one, so our lower one this time is 835. Our next bounds question then, so 8.40 has been rounded to 2 decimal places. Give the upper bound. So again, if I start with 8.40, always the same 2 symbols. Now with decimal places, if we want to find the bounds, we need to go to the next decimal place up. So the next decimal place for the upper bound, again, is a 5. So we're using 5s rather than 4.99s. So we've basically put a 5 on the end of this one. If I want the lower bound, I take 1 from this number and then put a 5. So I've got 40 here, so that becomes 8.39 and then the 5. We were asked for just the upper bound, so 8.405 for that one. Okay, let's have a look now at proportion. Now if you're not very good at direct and indirect proportion yet, I have just put a video onto YouTube about both of those topics. It's under the Year 10 Foundation playlist, so go and have a look at that if you need to practice proportion. We're being told that y is directly proportional to x, so we start with our proportional statement. Remember, this little sort of fish symbol is our proportion symbol. What we need to do is turn that into an equation first. So y equals the constant of proportionality multiplied by x. For direct proportion, we're multiplying by a constant, because as one gets bigger, the other needs to get bigger, and multiplying will make it bigger. We then need to find the value of k, so we substitute in our 2 values. So y was 8, and that's k times 4. Now we want just k. To get rid of a times by 4, I need to divide both sides by 4. So 8 divided by 4 will give me 2. So k is equal to 2. And finally, we put that back into our original equation here. So we get y equals 2x. So there's quite a few steps there if you haven't practiced this for a little while. Okay, question 10 then. Find an equation for y in terms of x if y is directly proportional, this time to x squared. Okay, so it's important we note that it's x squared. So we're going to do the same. Y is equal, again, direct proportion means I'm going to multiply my k by my x squared. Substitute in our values. So 8 is equal to k times 4 squared. 4 squared is 16. So this time to find k, I need to divide both sides by 16. Dividing this side by 16, it will go 8 divided by 16 equals a half. Let's find the space. So k is equal to a half. So again, we're substituting k into our original formula. So y is equal to a half x squared is our solution there. Alright, so that's all on numbers and calculating ones. So they were all non-calculator questions. Okay, I'll just move over, fold that back so we can find some space. Alright, so we're now moving on to algebra. Now I know I'm going to need extra paper for the algebra ones. Now the first thing I should say is that I noticed on the one that you were sent that this value here of 8x said 5x. So if you've attempted it with 5x there, you will find it doesn't factorise. I apologise for that. Obviously there was a typing error in the one that was sent to you. So please go back, change that to 8x if you've not managed to do that one. But we'll talk through the process because it will be the same on all of the next homeworks. Okay, so I'm going to do this on a piece of paper, a bit more space. So we have got 3x squared plus 8x minus 3. Now our first step with these, where the coefficient of x squared is greater than 1, is to multiply our first and last numbers together. So we get 3 times minus 3, which is minus 9. We're now going to find the factor pairs of minus 9 that will give us 8 for the middle. Okay, so factors of minus 9 are 1 and minus 9, or 3 and minus 3, or 9 and minus 1. Now if I add these together, 1 plus minus 9 is minus 8. 3 plus minus 3 is 0. And 9 plus minus 1 is positive 8. Now we wanted positive 8, so this is our pair here. Now remember, these two values are going to make up this middle number. So we're taking our quadratic from 3 parts back into a quadratic of 4 parts. So we're going to have our 3x squared, then our positive 9x, our negative 1x, so negative x, and then our negative 3 as well. So we're back to a 4-part quadratic. So remember, all we're doing with factorising is putting back into those double brackets. So we're going to split that down the middle, and we're going to linear factorise each of these parts. So we're looking for what's common. 3x squared and 9x have 3x in common. So I'm going to take out 3x. Remember, when we're factorising, we then have to multiply this to get back to the original. So what do I multiply 3x by to get 3x squared? I multiply it by x. And 3x to get 9x, I would have to multiply it by 3. Okay. Now I've got to do the same this side. Remember, there's negative 1, there's an invisible 1 here, and minus 3. So we're looking to see what's in common with these. Well, the only thing that's in common is minus 1. To get from minus 1 to minus 1x, I would have to multiply by x. To get from minus 1 to minus 3, I would have to multiply by positive 3. Negative times positive will give me negative. Now remember, these two brackets should always end up identical. If they don't end up identical, the same values, the same symbols, then something has gone wrong and you need to go back and do that step again. So finally, to finish factorising, then we take the two that are outside the brackets and they go together. So 3x and the minus 1 makes one bracket. And our final bracket is the one we've got there. So the one that we've got 2 of, we just take one of those. And we've factorised that expression. Okay, so we're going to put that into our box then. So 3x minus 1 and x plus 3 there. So you will need probably a bit of paper to do these slightly longer ones on. Okay, the next one then we've got, so we've got to solve the quadratic instead this time. Okay, so we're being asked to solve this quadratic. It's already been factorised for us. So to solve it, we take our first bracket and we say, well, that one could be the bracket that's equal to 0. So to find the value of x, to get rid of plus 1, I need to add 1 to both sides. To get rid of a multiply by 2, I need to divide both sides by 2. So x could be a half. We do the same with the other bracket. X plus 5 could equal 0. To get rid of plus 5, I subtract 5 from both sides. So x could be minus 5. So to solve this equation, x is equal to either a half or minus 5. So remember, there's always two solutions to all of our quadratics. Okay, question 13. Write x squared plus 8x plus 10 in the form x plus a all squared plus b. So this is completing the square format. So again, I do this on a bigger piece of paper so that we can see it. So x squared plus 8x plus 10 here. So remember, we complete the square on these first two parts only to start with. And we do that by splitting it. So x squared, we're going to say, is x, and we half the number. So we get 4, and that becomes squared. Our next step is to square this number that's in the brackets and subtract it. Remember, it's always subtract. So 4 squared is 16. So that's our completed square. we now need to bring down the final number here, which was plus 10, and group them together. So we get x plus 4 squared minus 16 plus 10 is minus 6. So that's now in the form x plus a, so a is 4 and b is minus 6. For that one. Alright, we're asked to do a similar thing again for the next one. So let's have a go with that one. So we've got x squared minus 2x plus 3, and we want it in that same format. So again, we're just going to do that on these first two parts. So we're going to split the x squared into x minus half the number, which is 1, and we're going to square it. We're going to square the number and subtract it. So regardless of this symbol here, we're always going to subtract. So 1 squared is 1, so we're going to take away 1, and we're going to bring down the plus 3. So x minus 1 squared minus 1 plus 3 is plus 2. So x minus 1 squared plus 2 for that one. Okay, our next one then. So the measurements of a box are doubled. What happens to its surface area? Well, if we imagine I have a box, okay, here's our box, and it's 1 by 1 by 1 currently. The area of each face is 1 times 1, which is 1. If I were to double the sides of the box, so my side of my box now is 2 by 2, well 2 times 2 is 4. So if the area of my original face was 1 and the area of my doubled size face is 4, it must be 4 times bigger. So it is now multiplied by 4, it is 4 times bigger. So we've got a plot needs 40 kilograms of fertilizer. How much will be needed for a plot with double dimensions? So again, we know the area is 40 and we're told the dimensions have doubled, so we know that that means we're now multiplying it by 4. So 40 times 4 gives us 160 kilograms of fertilizer. Alright, for the next ones then, we're going to need a calculator. I'll just find mine. There we go. So make sure you've got your scientific calculator handy for these next ones. Okay. So that little picture of a calculator really should be in this next box. We're not expecting you to do cosine without your calculator. Okay, we need to find the value of x to 1 decimal place, and we've got cos x. So we need to get rid of cos from this side. To get rid of cos, we need the inverse of cos, or cos to the minus 1. So what we need to do, paper, is to get rid of cos, we're going to move it to the other side. So we're going to have cos to the minus 1 of everything that we already had. Minus 9 squared over 2 times 4 times 7. Remember, we just wanted x, so to get rid of cos, we inverse cos, and that will give us the opposite. So we need to put that into our calculator, so we're going to put that in quite carefully. So shift and cosine to give us the inverse of cosine. I'm going to press the fraction button so that I've got my top and bottom lines that I can write in, and simply going to type it in as it is there. So 4 squared plus 7 squared minus 9 squared at the top, at the bottom 2 times 4 times 7, close my bracket at the end, and there we get our answer. So our answer then, we've got 106 point, now it says 1 decimal place, so sorry, can't see that very well. Next to our 6 is a 0, so the 6 will stay as 6, and that's in degrees if we were finding cos. Okay. We're now moving on to number 18 then. So this is using sine rule. Again, we want to find x. So our first step is simply to rearrange the equation. So we had x over sine 38 equals 8 over sine 60. Again, we just want x. So I've got to get rid of this divide by sine 38. To get rid of divide by something, we multiply by it. So I've got to multiply both sides by sine 38. If I multiply the original side, it will cancel, so I'll just get x. If I multiply this side, remember when you're multiplying a fraction, we're going to multiply the numerator. So if I'm multiplying a fraction by a whole value, it's just the numerator. So I get 8 sine 38. Now remember, your calculator will put an open bracket. You will need to close it. Over sine, and again, we will get brackets around there. So we're just going to put that into our calculator now as well. Okay, so we had our fraction button, because we've got a fraction, 8 sine 38, close the bracket, over sine 60, close the bracket. If you don't close the brackets, it will say maths error, so make sure you close those brackets. There we are, 5.687. Again, we want one decimal place, so 5 point, now we've got an 8, so our 6 will need to go up to a 7. Okay, so just rearranging those equations and putting them into your calculator for those. Alright, we're now moving on then to look at vectors. So we've got a couple of vectors questions here. Our first one, we've been given the vectors, so we've got A and B are two vectors. We're asked to add them. Adding them means that one follows straight on from the other. So if I were to draw vector A onto my grid here, so I can draw it anywhere I like, I'm just going to draw it near to the edge. So vector A has gone 1 across and 3 up. So starting here, 1 across and 3 up is here, and it's in that direction. Then from where I ended A, I need to draw B. That's 1, 2, 3, 4 across and 2 down. 1, 2, 3, 4 across and 2 down is here. So again, hopefully you will use a ruler. That's in that direction there. So A plus B must be from here to here, and it does have to have the arrow. If you don't draw the arrow pointing in the right direction, you won't get the marks for these questions. Okay, another way of thinking about these is if I wrote down the vector for A as a column vector, that's 1 and 3. Remember, to the right is positive and up is positive. And then I've got 1, 2, 3, 4, and minus 2 down is negative. And if I add those together, 1 plus 4 is 5, 3 plus minus 2 is 1. So I need to go 5 to the right and 1 up. And I've drawn my vector 5 to the right and 1 up. Okay, so if you're not confident doing it just with the diagram, write them as column vectors, especially if you're subtracting them here instead, because that can get a bit complicated. Write them as column vectors, find out what your resultant vector should be, and just draw that final vector onto the diagram, making sure your arrow is pointing in the right direction. Okay, our next one then. So if OX is 2A plus B, and OY is 4A plus 3B, express XY in terms of A and B. So essentially what they're saying is if we had a point here, and that's O, O to X is 2A plus B, so that's in some direction. Okay, so let's call that X is there, that's O to X. Then O to Y is in another direction, somewhere over here, let's say. So that's O to X going that way, and that's O to Y going this way. And we want to know X to Y. We want to know this distance between these two. Okay, so essentially we're going to add these together again because we want to get from one to the other where we know two different vectors. So if we add these together, we get 2A plus B plus 4A plus 3B. Collect the like terms just like we would in algebra, and we get 6A plus 4B. Alright, you might need to look up vector geometry a little bit more if you're getting stuck on these ones. Okay, finally then, let's look at this final section. Paper. Alright, so number 21, you've got to decide whether we're going to use sine rule or cosine rule. So the main difference then, so remember sine rule is all about pairs, and cosine rule is about included angles. So whenever we have a triangle, we'll call it A, B, C, opposite the angle, the smaller side, the side is called the lowercase letter, so that's A, B goes with B, and C goes with C. Okay, and that's true for both sine and cosine rule. Sine rule tells us that if we have pairs of these, we can find the missing ones. So we would be saying that A over sine A is equal to B over sine B. So we need to know some pairs. If we were using cosine rule, then we would need to know an included angle. So an included angle, for example, could be this one here. Alright, so for cosine rule, I need to know two sides, B and C, and I need to know the angle A. So it's included, it's between the two. So what you're looking for in your diagram is to see, do you have pairs or do you have one of each of the values? So in this case, we've got 154 and we've got X, so that's one pair. We've got 28 and 4, so that's another pair. So we would be using sine rule. Okay. If they'd given us in our diagram instead, so if that's the same diagram, if they'd said this is 154 and that one's 4 and 28 and this was X here, okay, we could be using cosine rule because we've got an included angle and our two sides. Alright, so that's what you're looking for, is whether you've got pairs or whether you've got an included angle. Okay, next one then. There are 288 boys and 432 girls in a school. How many boys would there be in a sample of 30 from the school? So this is stratified sampling. Stratified sampling, remember, is where we want the same proportion of students to be in our sample as are in the school. So we're talking about the boys. So there are 288 boys at the moment. And that's out of, so we'll write that as a fraction of all of the students in the school. So in the school, there are 288 plus 432. There are 720 students. So that's our proportion of the school that are boys, our fraction of the school that are boys. And we want that same fraction of being times the sample that we would like, so of 30. So in our calculators then, we're going to put 288 out of 720, out of then again of 30 gives us 12. So we would need to have 12 boys in our sample. Okay. Question 23, give the equation of this graph. Now this graph, you can see it's going along in angles. Alright, so it's either going to be a sine, a cosine or a tangent graph. It starts at 1. If it starts at 1 and goes down and back up, that's the cosine graph. So this is our graph of cosine. So we would say that y is equal to cos x. That would be our equation of this graph. Our next graph, again, we're going along in angles. So it's going to be sine or cosine or tangent. It starts at 0. At 90 degrees it's at 1. And you can check these in your calculator. You can put in sine 90, okay, and it will tell you it's 1. So this is the graph of sine. So y is equal to sine x is our graph for this one. Okay, we're putting in, if we put sine x, so if we put sine 90, it will tell me y is 1 in this case. You should recognise these. We did these a little while ago when we did trigonometry. Okay, and we drew these out in your book. So it's just a case of being able to identify which one is which. So sine and cosine, sine starts at 0, cosine always starts at 1. The tangent graph you will hopefully recognise because the tangent graph has these sort of lines that come down like this in separate little lines along the graph, and it has these dotted lines that go down the middles where the curve doesn't reach because it reaches infinity. I've drawn that a bit bizarrely, but the lines don't meet. Okay, so tangent you will identify really easily. Alright, finally then, Question 25. So this is actually one of the topics that we're going to be moving on to after half term, which is called circle theorems. So don't worry if you are not up to date on this one at the minute. This is the topic we'll be moving on to. So indicate two angles that you know are equal. Now, one of the rules of circle theorems is that alternate angles in alternate segments are equal. So this angle here and this angle here are the same, or you could say that this angle here and this angle here are the same. So this is called alternate segment theorem, but again, don't worry if you're not clear on that one at the moment. We will be looking at that in our next unit. Okay, well, I hope that's helped. I hope that's given you a chance to work through those questions. Again, next set of questions will have very similar questions on it. They will just have the numbers and the values changed. But do keep in touch. Let me know if there's anything else I can help with.